Hello and welcome again. Today we are going to be working on conditional statements, if-then statements. And we actually have a three-part objective. I can identify the hypothesis and conclusion of conditional statements. I can determine the converse, inverse, and contrapositive. And then also I can use truth values to determine the validity of a conditional statement. So there's lots of stuff packed into this one unit. So let's get started. All right, so conditional statements are if-then statements. Conditional statements are, so if P, then Q. If P, then Q. So the symbol for this, kind of like the mathematical way of writing it, is P arrow Q. When we see this, this is basically saying if P, then Q. So P is what we call the hypothesis, and it usually follows the if statement. So P is the hypothesis following the if statement. So it's like hypothesis, if hypothesis, then conclusion. And the conclusion typically follows after the after the then statement. Visually, the hypothesis is a smaller portion of the bigger conclusion. So like if I live in Mill Valley, then I live in the United States. So the hypothesis is the smaller one of the two. So now what I'd like you guys to do is to try to underline the hypothesis and circle the conclusion of each of these conditional statements. If it was Wednesday, then I have geometry class. So it is Wednesday is the hypothesis, the P, because it's after the if statement. I have geometry class is the conclusion because it's after the then statement. A number is an integer if it is a natural number. So it is a natural number is the hypothesis because because it comes after if, and then this time there isn't a then, but a number is an integer would be the conclusion. And remember, these are conditional statements. Now, write a conditional statement for each of the following. The midpoint M of a segment bisects the segment. Okay, so let's first identify the hypothesis. So the hypothesis would be the midpoint M of a segment. And then the conclusion would be bisects segment. Oops. All right. So therefore, if M is the midpoint of a segment would be the first part of the conditional statement, then M bisects the segment. Now let's take a look at this example. So now we're looking at the Venn diagram version. And remember, the hypothesis is the smaller one, and then the conclusion is the bigger area. So here the conditional is if an animal, and you can come up, it could be if an animal or if a thing is a tarantula, the hypothesis, then it is a spider. So if hypothesis, then conclusion. If hypothesis, then conclusion. So now we're going to look at something called truth values. And we're going to look at the conditional statement, if I get paid, then I will take you to the movies. Okay, so don't worry, I'm not going to take anyone to the movies anytime soon. So here we have the p-values, the hypothesis, and q for the conclusion. So if the hypothesis is true and the conclusion is true, then the conditional statement is true. So if I do get paid and I take you to the movies, this conditional statement is true. Now, if I get paid and then I don't take you to the movies, that would be a false statement. Now, let's say I don't get paid So false, that this hypothesis is false, so I do not get paid, and I still take you to the movies, this conditional statement is still true. It does not prove that this statement is incorrect. It doesn't say if and only if. It just says, if I get paid, then I'll take you to the movies. And then lastly, if I don't get paid and I don't take you to the movies, it doesn't prove that this conditional statement is false. So that's also true. So the only time a conditional statement is false is false only when the hypothesis is true and the conclusion is false. And the way the way that we figure out things are false is by coming up with a counter example. So the only way that we can prove that a conditional statement is false is if the hypothesis is true and the conclusion is false. So now we have 3 conditional statements, and I would like you guys to determine if these conditional statements are true. So if today is Wednesday, and for me right now it is Wednesday, then tomorrow is Thursday. So since today is Wednesday and tomorrow would be Thursday, this conditional statement is true. Both the hypothesis and the conclusion is true. Now, if an angle is obtuse, then it has a measure of 100 degrees. So the hypothesis is true. The hypothesis is true. If an angle is obtuse, it's true. But the conclusion is false. There are obtuse angles with measures other than 100 degrees. Lastly, if an odd number is divisible by 2, then 8 is a perfect square. So odd numbers can never be divisible by 2. So the hypothesis is false. So since the hypothesis is false, it doesn't matter. It does not pertain to this. So therefore, the truth value is true. This conditional statement is true. This is definitely the hardest for people to understand. So if we go back, remember, it doesn't matter if the hypothesis is false. The conditional statement is always true because it's not proving this statement wrong. It's basically like saying, if it rains, I wear a jacket, but when it's sunny outside, you still wear a jacket. That's fine because it's not proving that when it rains, you wear a jacket. So this one is false because the hypothesis, this one is true because the hypothesis is false. So now getting into our second objective, which is I can determine the converse, inverse, and contrapositive given a conditional statement. Let's look at to see what is a converse, inverse, and contrapositive. So like before, the conditional is if the hypothesis, then the conclusion. If P, then Q. And the symbol is P, then Q. The converse formed by switching the hypothesis and conclusion. So it's simply just switching. So if Q, then P. And so all we do is write Q arrow P, or if Q, then P. If conclusion, then hypothesis. And that's simply based on whatever the hypothesis and conclusion was from the conditional statement. Next is the inverse, and it's formed by negating both the hypothesis and the conclusion. So if not hypothesis, then not conclusion. If not P, then not Q. And how we symbolize not is with like a tilde or similar sign. So it's a squiggly sign, so not P, then not Q. And lastly, we have the contrapositive. And the contrapositive is basically a mixture of the converse and the inverse. It's formed by switching and negating the hypothesis and conclusion. So it's if not conclusion, then not hypothesis. If not Q, then not P. So it'd be tilde Q, arrow, tilde P. Squiggly Q, arrow, squiggly P. If not Q, then not P. Now, I'd like you guys to write the converse, inverse, and contrapositive, then find the truth values of each. So the conditional statement that's given is if an insect is a butterfly, then it has 4 wings. So we have our hypothesis, an insect is a butterfly, and we have our conclusion, it has 4 wings. So remember, the converse is conclusion, if conclusion, then hypothesis. So try to write the converse. If that's not right. If an insect, oh yes it is. If an insect has 4 wings, then it is a butterfly. If an insect has 4 wings, then it is a butterfly. Great. Now let's look at the inverse. Now the inverse is when we switch, is when we negate. Inverse is negate. Just like inverse operations kind of are like opposite of each other's. Opposite is like not. So it would be if an insect is not a butterfly, if an insect is not a butterfly, then it does not have 4 wings. So the key things here are not and not. And then lastly, the contrapositive is flipping and negating. So if an insect does not have 4 wings, then it is not a butterfly. So this is the conclusion. And here we have the hypothesis, and we'd have the nots as well. So the last thing that we're going to look at are logically equivalent statements. So it turns out that out of our 4 kind of related conditional statements, with the conditional, converse, inverse, and contrapositive, it turns out that some of them always have the same truth value. So related conditional statements that have the same truth values. So let's take a look at this example. So if the conditional is, if the measure of angle A is equal to 95 degrees, then angle A is obtuse. This is true. 95 degrees is an obtuse angle. Now the converse is, if angle A is obtuse, then the measure of angle A equals 95 degrees. So we can prove this false by using a counterexample that an obtuse angle can be 100 degrees. So this is false. The inverse is, remember, negating both the hypothesis and the conclusion. So if measure of angle A is not 95 degrees, then angle A is not obtuse. We can say, well, the measure of angle A could be 100 degrees, which is not 95 degrees, and still be obtuse. So this is false. And lastly, the contrapositive, negating and switching. So if angle A is not obtuse, then the measure of angle A is not 95 degrees. Right. So if it's not obtuse, it can't be between 90 and 180 degrees. So therefore we know that it's not 95 degrees. So this is true. So it turns out that the conditional and the contrapositive are always logically equivalent. So if the conditional is true, the contrapositive is true. If the conditional is false, the contrapositive is false. Same goes for the converse and the inverse. If the converse is true, then the inverse is true. If the converse is false, the inverse is false. And this is part of the reason why when we get to biconditionals, we only need to check these 2. So now that you have finished this lesson, I'd like you guys to please go back to my website and go to that quiz and try to complete the displaying of understanding. Thank you and have a good evening.